For the first problem, we have 15 grams of nitrogen reacting with excess hydrogen, producing 10.5 grams of ammonia, and we want to know what the percent yield is. Well, there's several pieces of information in this problem, so let's break it down. So first, let's look for what the actual yield is. Well, that is 10.5 grams of ammonia because it says that amount is produced. That is my actual yield, so I'm going to label that actual yield. And I'm actually going to kind of set up the problem right down here. So 10.5 grams is my actual yield. That needs to then go over my theoretical yield, and then I multiply times 100. Now, I also have in here that the nitrogen is reacting with excess hydrogen. Well, we know that that is important for the purposes of the problem. So we have plenty of hydrogen to react with the nitrogen, but it's not important for the math part. So we're just going to kind of cross that off. Now, the only thing I have left is 15 grams of nitrogen. So that's my starting point. So I'm going to start at grams of nitrogen, and I want to end with grams of NH3 to get my theoretical yield. So if we have 15 grams of nitrogen, first thing is I need to convert that to moles. Then I can convert that to moles of NH3, and then I can get to grams of NH3. Molar mass of NH3 is 17.04, and molar mass of N2 is 28.02. So if we are using this method, we have our game plan laid out. If we're using the poem, well, let's look at that. Balance the reaction, check, it's good. Given to moles, good. Mole to mole fraction, good. Mole to the goal. All right, so we have it all set up. Now we need to figure out what is our theoretical yield that would be produced from 15 grams. So I'm now ready to set up my train tracks. I'm ready to set up my math. So I have 15 grams of nitrogen. I put it over 1. Unit comes down. Grams nitrogen, moles nitrogen to the top. 1 mole of nitrogen has a molar mass of 28.02 grams. That would be mole to the goal. Done. Moles nitrogen comes down. I want to get to moles NH3. Now I look at my balanced equation. 1 is next to nitrogen. 2 is next to NH3. Mole to mole fraction. Check. That one's done. Now moles of NH3 come down. Grams of NH3 come to the top. 1 mole of NH3 is 17.04 grams. And so my units cancel. I'm at the goal of grams of NH3. I do my math, and I get 18.24 grams. Now that is my theoretical yield. That number is what needs to go at the bottom of my percent yield formula. So I take that number, I put it right down there, and then I do the math. I take the actual yield, which is the 10.5, divide by theoretical yield, 18.24, multiply by 100, and I get a percent yield of 57.6%. All right, example 2, we have 13.1 grams of CaO is produced when 24.8 grams of calcium carbonate is heated. What is the percent yield? So in that problem, there's one actual yield and then one substance that we need to get to figure out the theoretical yield. I recommend highlighting the actual yield, make a note, and so that is the number we're going to come back to later in the problem. So it says 13.1 grams of CaO is produced. That's my actual yield. So make a note that that's the actual yield. We use that number at the end. So that's the number that I'm going to put on the top. Now I need to calculate my theoretical yield. I do that from this 24.8 grams of CaCO3. So balance the reaction, check. Given to moles, so I have to take the 24.8 grams CaCO3, put it over 1 grams CaCO3 comes to the bottom, moles CaCO3 comes to the top. 1 mole of CaCO3 has a molar mass of 100.02. Now I can go from moles CaCO3 to moles of CaO. And I use the coefficients to 1 to 1, so it makes it very easy. Then the last step, mole of CaO to grams of CaO. So 1 mole, molar mass of CaO is 56.08. So now I have done balance the reaction, check. Given to moles, check. Mole to mole fraction, check. Mole to the goal, grams of CaO, check. Now cancel my units, get my answer, and the answer is 13.9 grams. Then what I do is that 13.9 comes right down here. That's my theoretical yield. So I take my actual, divide by my theoretical, multiply times 100, and I get 94.2% is my percent yield. This last example, we are looking for the percent yield when 4.65 grams of copper is produced when 1.87 grams of aluminum is reacting with excess of copper sulfate. All right, so the first thing, let's go through and let's identify what information is in the problem. So it says 4.65 grams copper is produced. Because that's the amount produced, that's my actual yield. And then it also says it reacts with an excess of copper-2 sulfate. So remember, when we're talking about stoichiometry, we don't need to do anything with that as part of the problem. It just means we have plenty of copper sulfate to react with the aluminum. So the only number I have left is the 1.87 grams. So that's my starting point. Now let's jump into our poem. Balance the reaction, check. Given to moles, so my given is 1.87 grams of aluminum. And I'm going to put that over 1. Grams of aluminum comes down. I want to get to moles of aluminum. 1 is going to go next to mole, and then I look at my periodic table. Molar mass of aluminum is 26.98. So given to moles, check. Next, I'm going to go mole to mole fraction. So mole of aluminum comes down. Moles of copper comes to the top. Now I have a 3 next to copper, so I put a 3 here. I have a 2 next to aluminum, so I put a 2 there. So now my mole to mole fraction, done. The last step is mole to the goal. So now I have moles of copper. I want to get to grams of copper. That's the goal. So I am going to put 1 mole of copper, and then I put 63.55 next to grams of copper, because that's the molar mass of copper. And then I cancel my units, and I get a value of 6.61 grams of copper. Now that is my theoretical yield. So to get my percent yield, I need to take the 4.65 grams of copper that was given here in the problem. I'm going to put that over my theoretical yield, which is 6.61 grams of copper. I multiply that times 100, and I get 70.3%.